Graphing sine and cosine in a different way than how we have before. It's going to end up being waves rather than a graph. So along what is traditionally our x-axis, we're going to have either degrees or radians depending on what you're working in. Now, I recommend when you're doing this on graph paper that you make each of your squares worth 30 degrees. It just tends to work out better, and that way every square and a half is 45 degrees. So because I don't have graph paper, I could probably do it on this, but whatever. I'm used to doing it without it. So we know that the same as on a Cartesian plane, there's 360 degrees. We're going to look at 360 degrees on our graph here. Now I'm going to break it up. You can be doing it on your graph paper. Like I said, every square is worth, say, 30 degrees. And what that would mean is that you would have 1, 2, 3 squares to get to 90, another 3 squares to get to 180, and so on. Now, along your y-axis, I recommend that you don't make like one square worth 1, but more like every couple of squares or every 3 squares is worth 1. Because, so what we're going to graph right now is we're going to graph y is equal to sine x. And so your x is your degrees. And again, you could just as easily do this in radians, and I'll do the next one in radians to show you. But if you do sine of 0 degrees, and you put that in your calculator, sine of 0, and you hit equals, you get 0. And so at 0 degrees, the height is 0. If you then go to the next big one, like don't go 30, 60, 90, you'll be here forever. But if you do sine of 90 and you put that in your calculator, that tells you 1. So at 90 degrees, sine is 1. If you then go to 180 degrees, sine of 180, if you put that in your calculator, it gives you 0. If you go to sine of 270 and you put that in your calculator, it actually gives you -1. And finally, if you put sine of 360 into your calculator, you get 0. So I have all these dots, and when I connect them, they create what we call a sine wave. Now we're only drawing one wave here, but technically this pattern continues in both directions. When I get you to graph one, you only have to graph one wave, okay? But we could keep this going forever and ever and ever if we wanted to. We just don't need to. So some of the characteristics of this graph that we're going to talk about, one is we're going to talk about the amplitude. The amplitude is really how high and how low does it go. So in this case, the amplitude is 1 because it goes up to 1 and down to -1. There's actually a formula for amplitude, and that is your maximum minus your minimum divided by 2. So in this case, it would be 1 minus -1, which is 2, divided by 2, which is 1. So it works out. Your amplitude is always the number that is right here. And in this case, there isn't a number, so we know it's just 1. So the other thing that we're going to talk about in this section is talking about period. Period is how long does it take to complete one cycle or one wave. For any sine or cos graph, a normal graph that we haven't done anything to in any way, the period is 360 degrees. Now there's a formula, and I'll explain it in a minute. The formula is 360 degrees divided by b. if you're working in radians, the formula is 2 pi over b. Now, where does that b come from? So we're going to talk about that. That b actually comes from, sometimes there is, so we talked about if there's a number in front of the sign, that is your amplitude. But sometimes there's a number in front of the x. So it'll be like sine 2x or sine half x or something like that. That is, the number that is here is your b. So if it was sine 2x, your b would be 2. And you would do 360 divided by 2, and you would get that your period is 180 degrees. And in the next example, in one of these examples, maybe not the next one, I can't remember, but in one of these examples, we're going to talk about that and we're going to discuss what happens. So that is a sine wave. A cos wave looks a little different, but it's quite similar. So again, we're going to draw, wow, that's not straight. We're going to draw, there's 360. We'll say that's 1 and that's -1. And there would be 180 and 90 and 270. So we're going to go through this again. But what we're going to do is we're going to do it for cos. So we're going to graph y is equal to cos x, just so we can see what it looks like. So if you put cos of 0 degrees in your calculator, it actually says 1. So it's up here this time. If you do cos of 90, it says 0. If you do cos of 180, it says -1. If you do cos of 270, it says 0. And if you put cos of 360 into your calculator, it gives you 1. So that when you do this wave, it ends up like this. And again, it can keep going in both directions forever and ever and ever. So a cos wave looks like this. So remember a sine wave, if I can just kind of graph really quickly, a sine wave looked like this. So you can see that dotted line there. That's a sine wave. A cos wave and a sine wave look exactly the same. If I was able to take and shift this cos wave over to here, right? If I was to take this point and move it to here, the cos wave would actually be right on top of the sine wave. So a cos wave and a sine wave are the same in that they're both a wave. It's their placement of where it is. Where is the start point, if you want to think of it that way. Okay, so in example number 2 of your textbook on page 206, they want you to graph y, whoops, helps if I have a pen, y is equal to sine x. There's a dog hair on my screen, that's lovely. And they want you to graph, and I do it a different color, they want you to graph y is equal to 4 sine x, and they want you to graph y is equal to 0.5 sine x. Now we're going to do all 3 of these on the same graph. So again, we're going to start with that black one, and I'm going to do this one in radians just to show you that it's the same. So if I draw my x-axis and my y-axis, now normally I would end at 360 degrees. Well, in radians, that's 2 pi. This would be 0. This would be 180, so that'd be pi. This would be 90, so that's pi over 2. And this would be 270, so that's 3 pi over 2. So it's the same thing, it's just written in radians. Pi over 2 is 90, then 180, then 270, then 360. Nothing's different. So if we're going to draw sine x, and just because it's in radians, if you want to think in degrees, I often think in degrees. I go pi over 2, that's 90. And so in my calculator, rather than switch it to radians, I just leave it in degrees and do sine of 90. But sine of 0 is 0. Sine of 90 is 1. Sine of 180 is 0. Sine of 270 is negative 1. That's going to be a problem later. And sine of 360 is 0. So that my sine wave looks like this. Now, they also want me to graph y is equal to 4 sine x. This 4 has to do with your amplitude. Whatever number is out in front, that's your amplitude. So just like when we were graphing parabolas, if there was a number out in front of the x squared, we multiplied our y values by that number. Well, just because it's sine x instead of x squared, we still do the same thing. Because that 4 is out in front, all we do is go through where the points were and multiply our y values by 4. So 0 times 4 is still 0. This is at 1. 1 times 4 is 4. So let's say 4 is up here somewhere. So it's here. 0 times 4 is still 0. Negative 1 times 4 is negative 4. I can't, let's say that's here. I know it's further down, but let's say it's there. And and 0 times 4 is 0. So that it goes up and it would continue down because we know negative 4 is further down. I just ran out of space. So there we go. So that is a graph that has a vertical stretch by 4. The amplitude is 4. So then we have the 0.5. The 0.5 sine x, again, I'm going to take that black graph, the original, the sine x, and I'm going to multiply all of the y values by a half. So this is still going to be 0, but this is at 1. 1 times a half is a half. This is going to be at 0. This is at negative 1, but we're going to go to negative a half. And this is going to be at 0. So when I graph it, so this is a vertical compression by a half. Same as when I was doing the parabola and I was doing all the transformations to it. This is the same thing. We're just transferring it to a wave. So now they want us, so in example number, let me see. Yeah, in example number 3. In example number 3, they put the number in a different spot this time so that it doesn't have to do with amplitude. So they want us to graph y is equal to cos x. They want us to graph y is equal to 2 cos x. Sorry, dog's barking. Just a minute. Oh, okay. I think they might be done barking now. You have no idea how long I had that paused. Okay, so they also want us to graph y is equal to cos x over 2. So we have a bunch of different things they want us to graph. So we are going to, I'm going to start here. I'm going to make it super long. And I'm actually going to put 360 about here. And 180 and 90 and 270. All right, there's a reason why I'm doing that. Okay, so again, if I'm going to graph just y is equal to cos x, cos of 0 is 1, and you can put this in your calculator. Cos of 90 is 0. Cos of 180 is -1. Cos of 270 is 0, and cos of 360 is 1. And again, you can just put that in your calculator, but after a while you don't need to anymore because you know what it looks like. Now, if they want me to graph y is equal to cos 2x, notice where this 2 is. It's not out in front. It's in between the cos and the x. That is your b. That is what that is. It is your b. So if I didn't ask you to draw it, and I just asked you what the period was, in degrees, you would do that your period is 360 divided by 2, which makes 180 degrees, which means you should have one full wave by the time you get to 180. If you were doing it in radians, you would do 2 pi divided by 2, and so your period would be just pi, which is 180 degrees. How you make that happen is exactly what you did with a horizontal stretch when you did the parabola. You actually divide your x values by whatever number is there. So 0 divided by 2 is still 0. 90 divided by 2 is 45. 180 divided by 2 is 90. 270 divided by 2 is 135. And 360 divided by 2 is 180. And so what happens is you have now horizontally compressed the wave so that it happens in half the amount of time. So if I asked you, what is that when there's a 2 there, you would say that is a horizontal compression by a half. So now what about the blue one? So with the blue one, think of that as cos 1/2 x. You are going to divide your x values from your black graph by a half. So 0 divided by a half is still 0, but 90 divided by a half is actually 180. And 180 divided by a half is actually 360. And 270 divided by a half is actually 540. So that's going to be here. And 360 divided by a half is actually 720. So this actually looks like this. So that is a horizontal expansion of 2. It is 2 times longer than the black graph. And so for that one, you would do 360 divided by a half, which would give you 720. There is one wave by the time you get to 720. Okay, so in example number 5, by the way, this was example, what did I do? I did example 3 and 4 all together. So in example number 5, they don't actually get you to draw anything, which is lovely. No more drawing. Let's take that away. So in example number 5, they give you y is equal to 2 cos x over 3. Now, if you don't like it like that, you could write it 2 cos of 1/3 x. Same thing. They want to know what is the amplitude, and what is the period. Okay, and so amplitude is easy. It's just whatever number is out in front. The amplitude is 2. Period is a little bit harder because remember, period is 360 divided by b. And whatever number is here, that's your b. So you're going to do 360 divided by a third. And if you put that in your calculator, you get that your period, I believe, is 1070. And so that is your period. You would get one wave by the time you got to 1070 degrees. That's all there is to that question. There's nothing else to it. Easy peasy. All right, so writing an equation from the graph. This is example number 6. So I'm going to very quickly, I'm going to just sort of sketch the graph that they give you in the textbook. So for example number 6 at 0, and then they kind of go up and down and back up. Okay, now in your textbook at the bottom of page 208, they label places here. We're going to talk about that in a second. So they want you to write an equation for this in the form y is equal to a sine b x. So you have to figure out what a is and you have to figure out what b is. We can do that because amplitude is just your maximum minus your minimum divided by 2. And so if we look at where is this maximum, where is that? If we look at that in your textbook, it looks like every square is worth a half, which means this would be 2.5 based on their picture. And the bottom here is at negative 2.5. So maximum minus minimum divided by 2. So that is 5 divided by 2, which is 2.5. So 2.5 goes here. B is, remember, period is equal to, now they have their x-axis in degrees. That's great. So they have 360 over b. We are trying to figure out the b. So what we have to figure out is how long is a period on this graph. So it starts at 0. One full wave would go up, down, and back up. So right there is the end of the first wave. So where is right there? When I look in the book, it looks like each square is worth 30. And so this looks like it's at 210 degrees because 180 is like right here and it's one square after. So 180 plus 30 would be 210. So my period is 210. That's equal to 360 over b. So I just multiply both sides by b. I'd have 210b is 360. So b is 360 over 210, which is just 1.5. So it's 1.5x. That is my answer. I have filled in what the A is. I have filled out what the B is. Same thing for example number 7, except this time they put the x-axis in radians. So again, if you're looking at page 209 this time, they give you a graph kind of starts up here, comes down, back up, down, back up. They give you a bunch of waves. So they say this is cos x, put in the A where it goes and put in the B. So if we look at the maximum, it's 1. If we look at the minimum on that graph, it's -1, which means the amplitude is 1. Now, because it's 1, you don't actually have to put the 1 there. I'm just putting it there so you know. Now, the B, because the x-axis is in radians, I'm going to do period, and instead of putting 360 divided by B, I'm going to put 2 pi divided by B. Now, one full wave is going to start at the crest, come back down, and come back up to the crest. That's the end of the wave. I mean, it keeps going, but that's the end of one cycle of the wave. If I look at where that is 2 pi over 3. So my period is 2 pi over 3 is equal to 2 pi over B. So now it's just a matter of solving that. So if I want 2 pi over 3 times B equals 2 pi. So then if I multiply this side by 3 to cancel out my 3's, and I multiply this side by 3, I have 2 pi B equals 6 pi. So if I divide this by 2 pi, so I just have B, gotta go down here. If I divide this by 2 pi, my pi's will cancel, and 6 divided by 2 is 3. So this is cos 3x. All right, I think I posted homework for this section. It would be page 209 is that homework. There's not a lot of graphing in it. It's more asking you questions. All right, so I will do the next video. Bye.